All right. So let's go over this warm-up and then we will get into our lesson for today. We were supposed to find the slope for the first three. That means using our slope formula, m equals y2 minus y1 over x2 minus x1. So I need to label my x1, y1 and my x2, y2. So up in the numerator, I would have negative 5 minus 3. Down in the denominator, we would have 2 minus 0. Negative 5 minus 3 is negative 8. 2 minus 0 is 2. And can I simplify negative 8 divided by 2? Yep, that's going to simplify to negative 4. So my slope for that line is negative 4. Same thing on number 2. Slope is y2 minus y1 over x2 minus x1. So we're going to label our x1, y1 and x2, y2. Does it matter which one you call x1, y1 and which one you call x2, y2? No. So if you flip it around the other way, you're still going to get the exact same simplified answer. Up in the numerator, we have 2 minus 2. And down in the denominator, we have negative 4 minus 1. So 2 minus 2, that gives me a numerator of 0. Negative 4 minus 1 gives me a denominator of negative 5. What is 0 divided by negative 5? 0. So this one has a slope of 0. That means it's a horizontal line. It has no rise to it. Number 3, again using our slope formula, y2 minus y1 over x2 minus x1. Label your x1, y1 and your x2, y2. So in the numerator, I would have negative 3 minus negative 1 over negative 4 minus 6. Up in that numerator, when we subtract a negative like this, hold on just a second. There we go. When we subtract a negative, it turns into a positive. So this becomes negative 3 plus 1 over negative 4 minus 6. Negative 3 plus 1 is negative 2. Negative 4 minus 6 is negative 10. What happens when I have a negative divided by a negative? Turns into a positive. So this becomes 2 over 10. And can that reduce at all? Is there anything that goes into both of them? Yep. 2 goes into both of them, so my final fully simplified answer would be 1/5. Numbers 4 and 5. How do I know if lines are parallel? What would I be looking for with the slope for them to be parallel? Yes. Same slope, yes. What about for perpendicular? What am I looking for? How do I know if they're perpendicular? Yes. That's absolutely correct. Opposite sign and flipped, which we call the reciprocal. If I have two slopes already and I want to see if they're perpendicular, the other thing I know is that perpendicular slopes will multiply to -1. So you could use either of those methods to determine if slopes are perpendicular. You're going to need to open up your books. Open them up to page 225. Page 225. So last week and beginning of this week, we talked about when I have two parallel lines, I know that at the beginning, and they're cut by a transversal. That makes different angle pairs congruent or supplementary. The ones that we learned about and talked about, those were back on page 209. You don't need to flip there. But we talked about corresponding angles. If my lines are parallel, then the angles will be congruent. Alternate interior angles. If my lines are parallel, then those angles are congruent. Consecutive interior angles. If my lines are parallel, these ones are supplementary. Remember, my consecutive ones and my linear pairs, those are the only ones that are supplementary. And then we also had alternate exterior angles. If my lines are parallel, then my alternate exterior angles are congruent. Today, our focus is going to be on proving that lines are parallel. So if I know angles are congruent, I can use that information to prove the lines are parallel. So the converse of my corresponding angles theorem, now I'm on page 225. If my corresponding angles are congruent, that means my lines are parallel. So this is the converse. Do you guys remember in the last module or for the last test when we talked about converse, inverse, and contrapositive? What does converse mean to do with my if-then statement? Just flip it. So my regular corresponding angles theorem says if my lines are parallel, then the angles are congruent. This is the converse of that, which says if my corresponding angles are congruent, then my lines are parallel. So we've taken it and flipped it around. We also have an alternate exterior angles converse, which says if my alternate exterior angles are congruent, then my lines are parallel. We have consecutive interior angles converse, which says that if my consecutive interior angles are supplementary, then the lines are parallel. And then we also have our alternate interior angles converse. So if my alternate interior angles are congruent, then the lines are parallel. So it's taking all of those theorems that we've been using where we know the lines are parallel first, and then we can say the angles are congruent or supplementary, and we're flipping them around. We're saying if the angles are congruent or supplementary, depending on the pair, then we can say those angles are, we can say those lines are parallel. Go ahead and flip to page 226. We're going to see how we use this in action. This is all going to rely on determining what the name of the angled pair is. That's how I'm going to know which converse I'm using. So in example number 1, part A, the first thing they tell me is that angle 2 and angle 8 are congruent. What's the transversal connecting those two? L is the transversal connecting those two angles. What would the name be for this pair? If L is my transversal, are they on the same side or opposite sides of that transversal? Opposite. What are the two lines that would need to be parallel then? A and B. Are these interior or exterior to A and B? Interior. So what do we call this angle pair? Alternate interior angles. So since we know those are congruent, we can say that line A is parallel to line B by the, what was the angle pair name again? Alternate interior angles converse. All right. Part B, angle 3 is congruent to angle 11. So here's angle 3. And here's angle 11. What's the transversal that's connecting 3 and 11? A. A is my transversal. Are those on the same side or opposite sides of that transversal? 3 and 11 are on opposite sides of line A. They're on the same side of line A. They're both on the right side of line A. What would be the two lines that would need to be parallel then? L and M. Are 3 and 11 both interior to L and M? Are they both exterior? I've got one of each. They're on the same side of the transversal, one interior and one exterior. Does anybody remember what we call that? Corresponding angles. So 3 and 11 are corresponding angles. So since we know that 3 and 11 are congruent, lines L and M would have to be parallel by the, what was the name that we gave to 3 and 11? Corresponding angles converse. All right, one more on this one, and then we'll do the check. We have that angle 12 is congruent to angle 14. Here's angle 12 down here, and angle 14 is all the way over here. What's the transversal that connects angle 12 and angle 14, the line that both of them touch? M. Are they on the same side or opposite sides of line M? Opposite. This one's above and that one's below. So what would be the two lines that would need to be parallel? A and B. Are these angles interior or exterior to A and B? Exterior. They're on opposite sides of the transversal and they're exterior angles. What do we call those? Alternate exterior angles. So since we know those angles are congruent, that means A and B would have to be parallel using what? Alternate exterior angles converse, yes. All right, let's go and look at the check down below. We're going to do this one together, and then we'll go on to example number 2. All right, so we have this given information here. We're told that angle 1 is congruent to angle 15. Well, angle 1 is up here. What are the two lines that angle 1 touches? L and N. So this line here and this line here. And then it tells us that it's congruent to angle 15. What are the two lines that touch angle 15? M and K. These two right here. What's the transversal that both of them touch? Or is there one? There's not one. Angle 1 only touches L and N. Angle 15 only touches M and K. So can we say that any of these lines would need to be parallel then? No. It is not possible to determine whether the lines are parallel. Angle 1 and angle 15 don't have any lines in common. So I can't make any statements about parallel lines. They have to have a transversal in common, and then I could say the other two lines are parallel. All right, let's look at part B. I'm going to erase what I've got up here so that we can look at part B without all the extra colors. Part B says angle 3 plus angle 10 equals up to 180. That means they are what? What word do we use for that? Supplementary. Does anybody remember the only 3 types of angle pairs we know of that are supplementary? Consecutive interior. What's the other 2? Consecutive exterior and a linear pair. Those are the only 3 that we have that are supplementary. So here's angle 3, and here's angle 10. We know they're supplementary. What's the transversal that connects them both? Sorry, which one touches both 3 and 10? L, right here. So they have line L in common. That's their transversal. So what 2 lines would have to be parallel then? N and K. N is parallel to K. Now we need to think about why that is. What would we call this angle pair? Same side or opposite sides of the transversal? Same, they're both on the right. Are they interior, exterior, or one of each? Interior angles. So what do we call that then? Consecutive interior angles. So we can say the lines are parallel because of the consecutive interior angles converse. All right, last one on this check, part C. This one tells me that angle 3 is congruent to angle 5. So here's angle 3, and over here is angle 5. What's the transversal that connects those 2 angles? N. So what would be the 2 lines that would have to be parallel then? L and M. So it can't be this one, and it's not going to be the bottom one because they have that transversal in common. What would we call this angle pair here? Alternate interior angles. So would this be A or B? A, the alternate interior angles theorem converse. Nice work. Great. I want to use these converses to solve some problems. We're going to look at example number 2 on the next page, page 227. We want to find the value for y so that lines E and F are parallel. I want this line to be parallel to this line. What do they give me to work with in the picture? I have this guy right here, right? What does that mean? It's a right angle. And how big is a right angle? 90 degrees. If I know that one is a right angle, What else do I know right around here? Everything else is a right angle. So this would be a right angle. This would be a right angle. And that would be a right angle. They're all 90 degrees. What else did they give me in the picture? Yep. They gave me the expression for y, and that goes with this angle right here. Is there a special name for this angle with this one? What's the transversal that connects this one and this one? D would connect those two. Are they on the same side or opposite sides of D? Opposite sides. Interior, exterior, or one of each? That one's interior, but that one's exterior. Do I have a name for ones that it's alternate, but one's interior, one's exterior? That's the only one I don't have a name for. But because we knew that that one up there was a right angle, that means I also know this one is a right angle, right? Do I have a name for this pair? What's the name for that one? Corresponding. What's the relationship between corresponding angles? Are they congruent or supplementary? Congruent. And what can I do with congruent angles? What do we know about their measurements? They're equal. So that means 4y plus 10 is the same size as what? 90 degrees. So I have that 90 equals 4y plus 10. What would I need to do here to solve this now for y? What do I need to do to solve that for y? Minus 10 from both sides. What's 90 minus 10? 80. And then what would I need to do after that? Divide both sides by 4. What's 80 divided by 4? Yep. Just a little louder, Deanna, you were right. 20. So y is 20. What did we use to be able to do that? What was the angle pair that we identified? Corresponding angles. So we used the corresponding angles theorem converse to solve this. Yes. So you mean like doing 4y plus 10 plus 90 equals 180? Is that what you're saying? It's not that it wouldn't make sense. It's that we were asked to do this so that lines E and F are parallel, which means I need one of my angles to touch line E. So it has to be one of those 90-degree angles up at the top and one angle that touches line F. So that's my 4y plus 10. If I use corresponding angles, those are congruent, so I would set them equal. But if I used this angle up here, these two would be consecutive exterior angles. And if I used my consecutive exterior angles to solve this, then I would say 4y plus 10 plus 90 equals 180, because that would be my consecutive exterior angles converse, because those are supplementary. So we could do it like that on this, but we would be using a different Converse. Does that make sense? Okay. We're going to do the check for example 2 tomorrow, and then we're going to get into some proofs. The homework that you picked up on your way in the door is due on Monday. You guys can get started. You should be able to do the entire front side and the first problem on the back side, although we are going to do some more problems that are like this tomorrow, and then we'll do some proofs. I hope you guys have a fantastic rest of your day. Just as a reminder, test is next Wednesday. Tomorrow is our last lesson. And then Monday and Tuesday we'll review for your test.